Okay, welcome back. In this lecture, we're going to talk about the F-sharp interactive and script files. So for the moment, I'm just going to close this program.fs file. We don't need that right now. And over here on the program.fs file, well, it opened it up there, but this is a temporary open here. And I'm going to right click on Program FS, and I'm going to go down here and select Add Below, Add New Item. And I'll talk about that in more detail. That has to do with the ordering of things, and you can change the order. You can move files around in their order. Order is very important, and we'll get to that in a future lecture in detail. What we want to select here in this create box is script file. And you'll notice down here it says script1.fsx. That's important. FS files are code files for compilation. FSX files are script files. And what I'm going to do here is put in module 1 script. That's good. And then we will add that. You can call it whatever you want, of course. So now we have a blank script file, and this is a place where we can write some F-sharp code and we can test it in a window called the F-sharp interactive window. And I'll show you how to open that now. We come up here to the View menu, and we go down to Other Windows, and somewhere down here, on mine it's all the way at the bottom, it's F-sharp interactive, but you can also press Control-Alt-F to open it, or you can select it here in the window. So I'll go back and I'll use the Control-Alt-F hotkey to open it. So press Control-Alt-F, and the interactive window is open. This interactive window, what it is in there is an F-sharp interpreter. And any F-sharp code that we type in here will be interpreted, and there's some special things we have to do. We can type directly into here. We can say something like 3 plus 4 and put a double semicolon at the end. That tells the F-sharp interpreter that's the end of what I'm typing. Otherwise, if you don't put the double semicolon, it will let you keep typing in before it gives you a prompt and executes anything. So it lets you put multi-line code in. So the double semicolon is simply an artifact of the command line of the CLI, the command line interpreter for F-sharp. So we'll hit enter, and it says it's a value of 7. So you can use it like a calculator. We can sit here and go something like let pi equal 3.141592658. Yes, I have pi memorized out to that many decimal places. I might be incorrect in the very last decimal there. I'm not completely sure. Anyway, so we've got pi, and we can do something like 2 times pi. And it doesn't like it. Why? Let pi equal. Okay. Well, that's a good error to get. So I wasn't thinking here. We need to do 2.0 times pi, and we should get it now, and we do. It's 6.28. The reason that gave an error is that 2 is an integer. Expects of type, or the type float does not match the type int. 2 is an integer. It's very strict about typing. There are ways that you can do it, but we'll get into typing and making the correct choices of types, and we'll also get into the fact that F-sharp has this type inference system. So most of the time you don't need to worry about the type, the exact type. Type inference allows the compiler to figure out what the type is supposed to be based on the context. Well, this would be typing here in the interactive is fine, but it gets annoying, and there's no way to save what you're doing here. When you close Visual Studio, anything you put in here would be gone. That's what this script file is for. The script file allows us to type some code, like let pi equal 3.14. We'll do that. we'll just go out to 2 decimal places for now. And we can say something like let 2 pi equal 2.0 times pi. And then we can put these in the interactive directly by highlighting them, everything that we want to go in, pressing and holding the Alt key, and pressing Enter. And it sent both of those down. You don't have to worry about double semicolons or anything. It sent both of them into the interpreter. The interpreter computed them, and here they are. These 2 values are now set in the interpreter. And we can save this file along with our project, and when we open the project later, anything we typed in here will be saved, will be retained. Good. So let's talk about these 2 statements, let pi and let 2 pi. These create, in this case, values. Values are immutable, at least in executing code, in compiled code, they're immutable. They are here too. However, for instance, we can't say, we can't just modify pi. We can replace pi in the interpreter. That's a slightly different process if we redefine it. If we run this again, for instance, say I wanted to add some additional decimal places, 3.14152658. I decided I want it really accurate. I can redefine it in the interpreter by pressing and holding Alt, sending it in, and it redefined pi. It really didn't change it like a variable. The interpreter has this ability to say, okay, well, in interpretation mode, I can redefine pi. If I were to have the compiler do this and say, let pi equal 2 in another place in the code, you'll see that the compiler is saying, hey, this is an error, duplicate definition of pi. We can't redefine it in the compiler. It is immutable. And for our purposes, we'll always think of them as immutable, even though we could change them in the interpreter. Immutability is very important. It is possible to make a mutable variable in F#, and we will come to that, and we will use it, and I'll show you how it's done. I highly recommend not using it unless there is a very particular need. There is, in fact, a way to get around the need for variables that change during execution, and it's a way of passing state. Let is also used to define functions. Let add a b equal a plus b is a function, and that function can be defined in the interpreter. And in fact, you know what, I'm going to go turn this keystroke thing off here now. I put it up there and I forgot to mention it, but I did put the keystroke indicator up so that you could see what I was hitting in terms of Control Alt or Alt Enter and so forth. But I think you've seen that, and it's kind of in the way down here, so I'm going to turn it off. So let add AB equals A plus B. It went into the interpreter, and the interpreter defined the value add as a function. That function takes 2 values, A and B, that are integers, and it returns an integer. That's what these arrows mean. But the arrows can be interpreted in a number of different ways. In this case, it says it's a function that takes 2 values, A and B, and returns an int. But it can also be a function that takes 1 value, an int, and returns a function that takes an int and returns an int. And that's literally what this is. It's either of those 2 things. And that is a matter of what's called partial application. And I'm going to go ahead and talk a little bit about partial application right now, but we're going to get into partial application in future lectures very thoroughly. But basically what I can do now is I can define it. Well, let's test add first. Let's say add 3, 4. And let's run that into the interpreter and see what happens. And it ran it. It executed add 3, 4, and it produced a 7. But what if I just said add 3 and I left the 4 off? Well, in languages that require all the parameters, this would be an error, right? It would say, where's my second parameter? I don't know what to do. in F sharp, and this is part of the reason we don't have parentheses and commas between things, is because it's not real strict about how many parameters you send. In fact, we can send in just a 3, and what we get back for an answer is this, int, right here. It says that the value that was generated by this call is a new function that takes an int and returns an int. And this is the function right here that it created. It didn't actually save it into anything, and we can't call it in the interpreter. But if we went something like let add 3 equal add with 3 after it and send this into the interpreter, now we have a value, add 3, that is a function that takes an int and returns an int, but it's got built into it or baked into it that first parameter, 3. And that's called partial application. If I now do add 3, 4, and run this, now I get 7, because it's calling the function add 3, which was returned by calling add with just one parameter, a 3. Bake the 3 into it. It now, add 3 now knows the first parameter. It knows 3, but it's got a new function, and that new function takes one parameter and returns a value by adding 3. It completes it. This is a very powerful tool, and the interpreter, the ability to save these, we'll be using this a lot. Conceptually here, just backing up a little bit, the purpose of this is you can test code here. You want to work out an algorithm, you want to work out the way some type works and the way you're going to handle it. You can do it here in script, test it in the interpreter, and once you're happy with the way it's behaving, you can simply copy that function out into a regular code file, such as what program is here, a code file, and use it in your actual code directly once you've worked it out here in the interpreter. So that's a basic overview of the interpreter, the script files, and what they're all for. In upcoming lectures, I don't know if it's absolutely the next lecture, but in upcoming lectures we'll talk more about file types. There's another file type that'll be very important to us, but we'll get into that when we start building our own modules with code in it that we can call. So anyway, that's the end of this lecture. Thank you for listening. I hope you enjoyed it and got something out of it, and I'll see you in the next lecture.